September 1946. The Waldorf-Astoria Hotel, New York City. The hotel has a private railroad siding below street level, and tonight Alco is using it. 3 locomotives sit on the tracks in warbonnet red and silver, the Santa Fe scheme, the most recognized livery in American passenger railroading. Each machine is 65 feet long, 14 feet high, and weighs 300,000 pounds. The streamlined nose tapers toward the rail, the way aircraft design was learning to taper toward air. Panoramic cab windshields curve into a sculpted steel nose that no other manufacturer has matched. The single prime mover under that hood produces 2,000 horsepower from 16 cylinders, the same output EMD's E-Series achieves by running 2 separate engines sharing a single shaft. One engine, 2,000 horsepower, the highest power density in American diesel passenger service. They are the most beautiful diesel locomotives ever built in the United States. Railroad executives from 17 roads are at dinner above them. The engine under that hood is already failing in a Gulf, Mobile, and Ohio freight unit 1,200 miles away. The crankshafts are breaking under load. Alco's field engineers are in the shop in Mississippi rebuilding them. By 1969, the company that built those locomotives ends 121 years of continuous production at Schenectady with a single corporate memo. One decision, made 5 years before that dinner, made both moments inevitable. Have you ever watched an institution bet its reputation on something it knew wasn't ready? Drop it in the comments. This is what American Iron Works covers. Subscribe so you don't miss what's next. In 1939, the electromotive division of General Motors runs a diesel locomotive called the FT on a demonstration loop across 21 states. The loop takes 11 months. The FT hauls freight in Wyoming, winter cold, over mountain grades in California, through southern humidity that corrodes steam components in a single summer. It does not need water towers. It does not need ash pits. It does not need roundhouse crews trained on a specific boiler configuration. The infrastructure that steam requires to function, the physical infrastructure. American railroads have spent 80 years building. The diesel does not need any of it. It runs, every time, in conditions that exposed how much overhead steam demanded just to move freight. Every locomotive superintendent in the country reviews the fuel consumption figures. Steam has moved American freight since before the Civil War. The 1939 demonstration does not kill it tomorrow. It does something more damaging. It makes the question of when unavoidable. The roundhouse at a major terminal employs 50 mechanics, 3 boiler inspectors, and a full-time fireman trainer. The diesel version of the same terminal, a decade later, runs on 18 mechanics and a parts catalog. For a railroad with 20 major terminals, that arithmetic is decisive. The railroads running that math in 1939 are looking at their coal docks and water towers and running a different kind of depreciation schedule than they ran the year before. At that moment, 2 companies hold 86% of the American locomotive market between them. They have held positions like this for 30 years. Their order books run from Maine timber lines to California citrus roots, from Texas cattle trains to Great Lakes ore hauls. Their plants are the largest manufacturing complexes in the northeastern United States. The larger of the 2 sits at the edge of the Erie Canal in Schenectady, New York, the American Locomotive Company. Alco. The works on this site trace to 1848. In 1901, 8 separate manufacturers merge. The Schenectady Locomotive Engine Manufactory, the oldest of the 8, has been building locomotives at this site since the Erie Canal was new. Alco is incorporated, headquartered at Schenectady, and within 5 years of the merger, it is the 2nd largest locomotive builder on Earth. The city doubles around it. Schenectady's population runs 31,000 in 1900. By 1910, it is 72,800. General Electric is 2 miles across town building turbines. Alco is at the canal. 2 industrial operations in 1 mid-sized city in upstate New York. Through the 1930s, Alco holds 47% of the American locomotive market. Baldwin Locomotive Works holds 39%. Alco does not hold that share by producing the cheapest locomotives. It holds it because when a railroad orders an Alco locomotive, it gets exactly what the specification says, and the machine runs for the contracted service life. 30 years of exactly that is what 47% market share looks like in a capital equipment industry. A railroad does not change locomotive suppliers on a whim. It changes when the delivered product fails to match the specification. That 30-year record is about to become part of why nobody acts on the 1946 failure reports quickly enough. The same reputation that built the market share becomes the reason the early service failures get explained away as fixable field problems rather than recognized as evidence of a systematic testing failure. Then the FT completes its loop, and the question of when becomes the question of how fast. Alco moves. In 1940, it forms a formal partnership with General Electric. Alco builds the locomotive bodies and prime movers. GE supplies the electrical gear and service infrastructure. The partnership gives Alco something it does not have independently: GE's service network, GE's marketing relationships with railroad electrical departments, and GE's credibility as a large industrial corporation standing behind the product. In March 1941, Alco introduces the RS-1, the first road switcher locomotive. The Rock Island Railroad approaches Alco wanting a single machine that can handle mainline freight runs and switch yards, two jobs that require two separate equipment types at the time. Alco's designers create the hood unit, two hoods at different heights, a low short hood at one end, and a taller long hood covering the engine, crew cab between them. The visibility from the cab is better than any cab unit locomotive on the market. The trucks handle higher speeds than a conventional switcher. One machine, two categories of work. That format, the hood unit, the road switcher configuration, is the format every diesel locomotive in the world uses today. Every freight diesel moving coal through Wyoming. Every locomotive on the Union Pacific and BNSF networks. Alco designed the architecture that its competitors would later build their dominance on. The RS-1 stays in production for 19 years, the longest run of any American diesel locomotive. The first 13 RS-1s go into commercial service on American railroads in 1941. They are there 4 months before the Army takes them. December 1941. The calculation changes entirely. Alco converts the Schenectady plant. Walk through it at second shift in the spring of 1943. The smell reaches you before anything else: hot iron from the foundry, cutting oil from the boring mills, the sharp chemical bite of hydraulic fluid from the stamping lines. The noise after that is the percussion of 2-ton presses, the steady whine of horizontal mills cutting steel billet into locomotive frames, and the rising scream of a completed engine running up on the acceptance dynamometer before the test tag goes on the block. Conveyor lines move cylinder castings past inspection stations running around the clock. The women working those stations, and by 1943 most of the quality control workers are women because the men are overseas, gauge bore tolerances to the nearest thousandth of an inch on components bound for armored vehicles. Employment has climbed from 5,950 in 1941 to over 15,000. Every completed unit is going somewhere a soldier or sailor needs it to work. The output of this plant in the 4 war years: 2,300 M4 Sherman tanks, 3,300 M7 tank destroyers, 2,300,000 artillery shells, 410,000 fragmentation bombs, 4,488 locomotives for Allied railroads across 6 continents. The 13 RS-1 locomotives the Army took from American railroads go to Iran. The Army extends the Trans-Iranian Railway to the Soviet border, routing around the German naval blockade in the north and keeping Soviet supply lines open. Road switcher locomotives built in Schenectady for Illinois branch lines move material toward the Eastern Front. Alco earns a wartime reputation that becomes part of what kills it. The War Production Board, administering industrial allocation in 1942, examines the diesel locomotive situation and makes a logical decision. EMD has a proven mainline road diesel in revenue service with a manufacturing system behind it. Alco has a growing diesel switcher line. The board allocates mainline road diesel production to EMD and assigns diesel switches and steam locomotives to Alco. The allocation is efficient. It is also the decision that predetermines 1969. EMD builds mainline road diesels from 1942 through 1945 in quantities that establish the F-Series as the default freight specification for American railroading. Maintenance departments learn the 567 engine from hands-on service. Parts depots stock its components and know which ones where first. Railroad operating officials document what an F-Series locomotive costs per mile over 12 months of revenue service. When peacetime fleet conversion begins in 1946, EMD has 4 years of that documentation to present to every purchasing department in the country. Alco is presenting a locomotive whose prime mover has not finished its acceptance test sequence. In 1940, Paul Vaughan begins design work on Alco's road diesel engine. Vaughan is the chief engineer of diesel engine design at Schenectady. The first program is the 241, a V-type diesel, 9-inch bore, 10.5-inch stroke, designed to produce 1,500 horsepower. Development runs into problems at Alco's McIntosh and Seymour subsidiary in Auburn, New York. Testing data is not meeting management's targets after 4 years. In early 1944, Alco's senior management makes a decision. The company appropriates separate development funding for a new engine, the 244, and commits to getting it into production as soon as possible. The deadline is the end of 1946. The reasoning holds from inside the building. Post-war fleet orders will begin in 1946. Contracts signed in 1946 and 1947 lock in supplier relationships for a decade. Alco needs road diesel product in revenue service before that window closes, or the company becomes the option. No purchasing department evaluated. Setting the deadline is not irrational. It is a competitive decision made by men who understand that an engine still in development, while EMD consolidates the market, is not a safe position to hold. The 244 development starts. Vaughan redesigns the block for mass production with new connecting rods, redesigned main bearings, and a block casting modified for volume manufacturing. In August 1945, the first 244 engines come off the test stand. The first 12-cylinder unit ships from Auburn to Schenectady on October 22nd. A second follows on November 13th. One engine goes into a test cell in Building 37. The test runs 24 days from November 23rd to December 17th, with 6 shutdowns to fix minor problems. Results are reported positive at an Alco sales meeting held December 17th through 20th. 600 hours on the test stand. 600 hours at rated RPM translates to roughly the same load cycle as an interstate truck engine running 25,000 road miles. The locomotives Alco is about to ship will run 200,000 miles per year under full freight load. Production of the first FA1 freight locomotives begins in January 1946. The 244 engine testing is not complete. 6 new locomotive model lines launch in 1946, all powered by the 244. The engines fail in service that winter. Gulf, Mobile, and Ohio Railroad holds a standing order for 80 freight diesel units. The first 20 FA1s it receives carry crankshafts that break under sustained load. Alco pulls the units and rebuilds them with forged steel replacements. The forged versions also fail. The problem traces to metallurgical flaws in components from an outside supplier. The cylinder liners crack. The dry block design, where the cast iron block and water jacket are separate components, expanding at different rates under sustained mainline heat, produces cracking at the interface under load conditions the 600-hour test did not replicate. The GE turbochargers develop their own independent failure patterns. A crankshaft failure in a freight locomotive is not recoverable in the field. The locomotive comes off the train. It goes to a shop. The carrier moves freight around the gap in its consist for weeks. Every railroad that signed an Alco order in 1946 has a maintenance manager running that cost calculation alongside the EMD F-Series figures from other roads. In capital equipment markets, the maintenance log is the sales document for the next purchase cycle. A railroad changes locomotive suppliers because the log from the past 4 years says the current one is costing more per mile than the alternative. EMD's 567 engine logs months between service stops on the same routes. FA1 and FB1 freight units are in service on the Baltimore and Ohio, the Lehigh Valley, the Rock Island, and the New Haven. PA passenger units, powered by the same 244 engine whose crankshafts are breaking in the Mississippi shop, arrive at 17 railroad customers in colors that make them the most visually distinctive locomotives on the continent. From the outside, Alco is at the peak of its diesel market position. From inside the Schenectady plant, the service teams are tracking which units need to come offline and why. In 1948, Alco holds 40% of the diesel locomotive market. The peak. From inside the building, that number looks like a foundation. It is the high water mark before the service records from 1946 and 1947 migrate from the maintenance shop into the purchasing office. In 1951, Paul Vaughan starts the program that should have been the 244, the 251 engine. Vaughan redesigns the block as a wet casting, cylinder liners surrounded directly by coolant rather than relying on a separate water jacket, eliminating the thermal differential that fractured the 244's cylinder liners under sustained mainline service. He adds an intercooler for the turbocharger. He rebuilds the crankshaft, bearing, piston, and injector specifications using the 244's documented failure record as a design exclusion list. And every mode in which the 244 failed becomes a structural requirement the 251 must prevent. What that means in practice is the first production. 251 does not go into a revenue locomotive until the failure modes that ended the 244 have been tested for and eliminated. The crankshaft specifications come from field failure data. Alco's service teams documented between 1946 and 1951, not the test cell data the 244 was approved on. Vaughan used the 244's failures as the design specification. He puts the 251 through nearly 5 years of testing before it enters domestic production. The 251 works. It is the engine the 244 should have been in 1946. It enters domestic service in 1954. In 1953, General Electric dissolves the partnership with Alco. General Electric's executives have put their reasoning on paper. Alco's reliability problems are documented in General Electric's service records. Every General Electric electrical system installed in a failing FA or PA unit connects General Electric's brand to a failed locomotive in a customer's maintenance shop. The reputational exposure is quantifiable. A refrigerator assembly line at General Electric's Erie, Pennsylvania plant is moving to a new facility in Louisville, freeing factory floor space for locomotive production. General Electric exits and becomes Alco's competitor. The U-25B enters domestic service in 1961. Within 4 years, General Electric displaces Alco as EMD's primary competitor in North America. At dissolution in 1953, EMD holds 62% of the American diesel market. Alco holds 24%. By 1960, Alco's share is 13%. The company that replaced Alco as America's second largest locomotive builder was the company Alco spent 13 years partnered with. Which decision closed that window, the 1944 deadline or the 1953 dissolution? Drop it below. In 1963, Alco introduces the Century Series, the C420, the C424, the C628. Locomotives powered by Paul Vaughan's 251, 5 years tested and 9 years in field service, operated without the crankshaft failures that defined the 244's first winters. Alco's engineers redesigned the air systems, the traction control, the accessibility panels. The case at the January 1963 unveiling in Chicago was clear. Century locomotives could reduce operating costs by 44% over the machines they replaced. The C628 sells 186 units between 1963 and 1968. EMD's SD40, introduced the same year, sells 1,257. 3 C636 demonstrators are built at a cost of approximately $5.5 million. During evaluation on the Santa Fe Railway, the same traction motor blower on demonstrator 636-2 fails on 3 of the 4 test runs. The railroad that ordered the first war bonnet PAS in 1946 passes. In January 1969, Dorald H. Ruttenberg becomes president of Studebaker Worthington Corporation, which absorbed Alco products 5 years earlier. Ruttenberg pledges to eliminate financially unsound components. The Alco Products Locomotive Division is first. 121 years of continuous locomotive production at Schenectady ends. Design rights transfer to the Montreal Locomotive Works. Employment that peaked at 10,000 workers in 1951 falls to 2,000 by 1960 and to 0 in 1969. The engineers who joined the division in the late 1940s because it was the best diesel program in America, those who worked on the 251 with Vaughan and who knew exactly what the 244 had cost, watch their best designs wait for funding that does not fully arrive. Some of them leave through the 1960s. Some stay because they believe the corporation will eventually see what it is losing. The ones who stay are there on the last shift in 1969 when the test stands shut down. The knowledge of how those engines ran, what they needed, and what the difference between the 244 and the 251 felt like in service does not transfer to a document. It leaves with the last shift and does not come back. Walk past the Schenectady site today. Some of the plant footprint is parking. Some is repurposed industrial space. The Erie Canal runs along the western edge, unchanged. The freight on the highways near Schenectady runs on engines built thousands of miles from the factory, a routine that gave the road switcher locomotive its format. There is something the dissolution memo does not address. Paul Vaughan's 251 engine does not die in Schenectady. Fairbanks. Morse Engine manufactures the 251 design today under the FM Alco brand for marine and stationary applications. In Varanasi, India, the Diesel Locomotive Works produces the WDM2 locomotive on a design license from Alco's 251 program. The WDM2 and its successors are among the most numerous diesel locomotives in the world. Alco's management chose not to give that engine adequate testing time in 1945, and it became a continental rail standard on a different continent. The institution that made that choice is a parking lot. The engine is still running. What the 1944 deadline cost is not counted in the crankshaft rebuilds or the PA repowerings or the collapse from 40% to 0 over 21 years. What it cost is the compounding. Every year from 1947 to 1953, Alco's service teams were managing 244 failures, instead of building the fleet relationships that determine the next decade's order books. Each railroad that standardized on EMD during those years did so because the maintenance record said to, and standardization in capital equipment markets does not reverse on its own. The engineering resources Vaughan needed to develop the 251 were being spent correcting an architecture that a December sales meeting had declared acceptable. The company that invented the format every diesel locomotive on Earth uses today ended because its institution could not give its own engine 6 more months. Vaughan's engine survived. The institution did not. If the kind of history nobody records is the kind you want more of, subscribe to American Iron Works.